All right, let's just jump right in. Today, we're venturing deep into the shadows of the cosmos. We're going to be exploring the echoes of forces that literally shape everything we see, but they remain completely invisible. This is going to be a good one. So, what if I told you that everything you've ever seen, I mean, every star, every planet, every single galaxy you can imagine, all of it makes up less than 5% of the universe? It's a staggering thought, right? The other 95% of the cosmos is made of two incredibly mysterious components we just can't see or touch. It's a cosmic mystery so profound it actually dictates the fate of reality itself. And look, this isn't just some fun little thought experiment. As our source material so perfectly puts it, prepare to have your understanding of the cosmos shattered. We're not just talking about abstract theories here. We're talking about the unseen architects of the entire universe, the puppet masters pulling the strings on the expansion of space itself. So let's start our investigation. First up, the great cosmic mystery. I mean, how did we even figure out that 95% of everything was missing in the first place? This visual, wow, it really puts it all into perspective, doesn't it? That tiny little sliver, less than 5%, that's what we call normal matter. That's you, me, the Earth, the sun, all of it. The other two giant chunks, dark matter and dark energy, are the real dominant forces in the universe. And the craziest part, we have almost no idea what they actually are. So the first hints of this cosmic mystery started popping up from observations that just, well, they didn't add up. Astronomers were looking at galaxies and they noticed something really bizarre. The stars way out on the edges were spinning so incredibly fast that the gravity from all the visible stuff, all the stars and gas we could see, it just wasn't enough to hold them in orbit. They should have been flung right off into deep space. And then came the second major clue. We can actually see the effect of all this missing mass. You see, light from really distant galaxies gets bent and distorted as it travels through space, almost like it's going around some massive invisible object. They call it gravitational lensing, and it's kind of like seeing the footprint of a ghost. We know something is there because we can see the gravity it's putting out. Okay, so this leads us to our very first suspect in this cosmic lineup, what we're calling the universe's hidden glue. That something is what we now call dark matter. It's this invisible substance that provides all the extra gravity needed to hold galaxies together. The source material uses this great analogy, calling it the gravitational scaffolding of the cosmos. And honestly, without it, the universe as we know it, well, it wouldn't have been able to form the huge, complex structures we see today. You know, in science, it's often easier to figure out what something isn't. And scientists are pretty sure it's not just regular stuff that's hard to see, because that would give off particles we could detect. It's not antimatter, that would create a really specific gamma ray signature. And it's not a universe just filled with massive black holes, because its gravity is spread out all over the place, not concentrated. This whole process of elimination really helps narrow down the search. Which, of course, brings us to the leading candidates. Think of these as the main persons of interest in our cosmic investigation. The suspect list includes things called WIMPs, which are massive but hardly ever interact with anything, axions, which are incredibly light, and machos, which are basically dense, dark objects. Let's just focus on WIMPs for a second, because they're a huge focus of all the research. The name really says it all. Weakly interacting massive particles. These things would be like ghostly particles that could pass right through you, me, and the entire planet Earth without even noticing. And that is why they are so maddeningly difficult to find. But make no mistake, the hunt is definitely on. Deep, deep underground, shielded from all the cosmic rays from space, there are these massive experiments like Lux Zeppelin and Xenon X. They are basically giant, ultra-sensitive detectors, and they're built for one reason: to listen for the absolute faintest whisper of a dark matter particle bumping into a normal one. It's an incredibly hard task, but if they find something, it could change physics forever. But remember, dark matter is only about 25% of the universe. Now we have to turn to the biggest and, frankly, the weirdest slice of the pie, the true accelerating enigma. So for most of the 20th century, we knew the universe was expanding. We have Edwin Hubble to thank for that. The big question was always whether gravity would eventually slow that expansion down, maybe even pull it all back together. But then, in the late 1990s, observations of distant exploding stars, supernovae, revealed a shocking truth. The expansion wasn't slowing down at all. It was speeding up. This discovery basically launched a brand new cosmic tug-of-war.
On one side, you've got gravity, always trying to pull matter together. But on the other side is this mysterious, repulsive force pushing everything apart, a force we now call dark energy. And here's the kicker. Right now, dark energy is winning.
And hey, if you thought dark matter was strange, the theories for dark energy are even wilder. Could it be a cosmological constant, some kind of intrinsic energy that's just built into the fabric of space itself? Or maybe a chaotic phantom energy that actually gets stronger over time? Or something called quintessence, a mysterious energy field that has the exact opposite effect of normal matter. We just don't know.
So what does all this mean? Well, the answer to the dark energy question, it's going to decide everything. It will determine our universe's ultimate fate. For billions of years, you can think of dark matter as the master sculptor. Its gravity pulled matter together to form this vast cosmic web of galaxies. But as the universe kept expanding, dark energy's influence just grew and grew. And today, there's no question, dark energy is in control. This new dominance leads to some pretty terrifying possible futures. One of them is called the Big Rip. In this scenario, dark energy's repulsive force gets so strong that it eventually overwhelms gravity on every single scale. First, it'll tear entire galaxies apart. Then, solar systems. And finally, it would become so powerful, it would tear the very atoms that make us up, literally ripping the fabric of reality itself apart. Of course, there are other possibilities. The Big Freeze would see the universe just expand forever until it becomes a cold, dark, empty void. And then there's the Big Crunch, which imagine the universe reversing course and collapsing back in on itself, though that one's considered less likely now. Our entire cosmic destiny really just hangs in the balance. Now, this all sounds pretty cosmic and abstract, I know, but the search is very, very real. And that brings us to our final section, the quest for answers. We are pushing the absolute boundaries of technology to solve this mystery. We've got missions like the James Webb Space Telescope peering all the way back to the dawn of time to see how the very first galaxies were sculpted by dark matter. And at the same time, the Euclid telescope is building this massive 3D map of the cosmos to track how dark energy's influence has changed over billions of years. And we're opening up entirely new windows on the universe. This new field of gravitational wave astronomy, where we detect ripples in space-time itself, might actually let us see these dark components interacting in ways we've never been able to observe before. It could provide a whole new set of clues. And that right there, that brings us to the ultimate prize. The secrets are out there, hiding in the echoes of the cosmos. The whole quest leads us to this final, tantalizing question. What single unified theory could finally explain all the forces and all the components of our strange and beautiful universe? The search has really